right, hello everybody and welcome to the 2020 UCSB Electrical Engineering Capstone Expo. Wow, it's been quite a year. So for those of you who are new to this event, capstone projects are team projects completed by seniors at the end of their academic degree programs. And in most years, our electrical engineering department here at UCSB teams up with the UCSB mechanical and computer engineering departments, and we hold a big college-wide engineering design expo featuring all of our capstone projects. However, this year, since we're forced to do this remotely, we decided to hold separate events so that we'd allow more time to feature each of our teams. So I see we've got quite a few, I'm looking at the participant list, I see we've got quite a few industry partners here and faculty members and mentors and family members and friends who've joined us today to celebrate our fantastic students. And my sincere thanks go out to all of you. And I just ask that you please bear with us in case we run into any technical issues. We'll do our best to resolve them as quick as we can. So I'd like to start out by introducing our instructional team. So my name is Ilan Ben Yaakov. I'm a faculty member here in the Electrical and Computer Engineering Department. And Professor Reza Abduli and I are the instructors for the Electrical Engineering Capstone course. And we're joined by three outstanding TAs, Evan Blasman, Blake Diamond, and Eric Roston. So all three of them were previously students in this course. They completed UCSB Electrical Engineering Capstone projects while they were undergrads, and now they're completing their master's degrees and were signed on as TAs for the year. And all three of them did an outstanding job providing tremendous support and guidance to all of our students throughout the year. So I'm extremely grateful to all of you for all the work that you put in helping plan this event and just in general throughout the entire year. We couldn't have done this without all of you. I also wanted to give special thanks to John Jacobs and Paul Hoff. So John and Paul are industry veterans who've been working with us for many years. They volunteer their time. They come to campus weekly and work with our multidisciplinary teams. And we're really, really lucky to have people like you in our community who can join us and help out and contribute your time and skills. And we can't thank you guys enough. Okay, so I'm gonna pass the mic over to Reza Abduli, and Reza is gonna tell you a little bit more about our program.
Hello, can you hear me?
Yeah, you're good.
All right, welcome everybody. Thank you for joining us this afternoon to virtually showcase electrical engineering capstone projects. Before we move on to the main part of our program, I would like to share a few thoughts about the capstone mechanics at UCSB and the reason that we are all here today. The UCSB Engineering Capstone program is a project-based course offered to undergraduate engineering students. The program focuses on the development of our students into professional by pairing students with experts from industry and academia to create an engineering solution for real-world problems with an ultimate aim of product commercialization and entrepreneurship preparation. Every year we plan the capstone a few months before the academic year begins. We start the process by reaching out to local industry and our faculty, inviting them to participate in the program and submit their project proposal. We review the proposal and select the outstanding project ideas that are innovative and at the same time feasible to implement during one academic year. This year we had more than 15 industry partners that presented their finalized project proposal in the event last September. Among those, 6 industry sponsored projects and 5 faculty proposals have been won in the competition. Among these 11 capstone projects, 3 were multidisciplinary and 8 were electrical engineering focused projects. Throughout the year, capstone students have been holding regular meetings with their industry sponsors or faculty mentor to exchange ideas and make sure that the design requirement and expectation have been met. Industry partner and faculty mentor have invested a great deal of time and energy to make this project a success. One of the reasons that we are here today is to express our gratitude to these key contributors that were with us in 2019 and 2020 academic year. First and foremost, we would like to thank all the corporate sponsors for their help throughout the Capstone project. Thanks to each of you for sharing your time, talent, energy, and resources with us. Without such support, we would be unable to educate students and conduct high-quality research to create positive changes in the world. We find that corporate sponsored projects really prepare the students for professional practice. The students acquired a sense of not only the technical aspect of the project, but also learn about budgeting, scheduling, deliverables, agile methodology, teamwork, and the culture of a working environment. We also would like to thank all mentors, including faculty, corporate mentors, researchers, and all volunteer individuals that were with us during the past year and contribute to these projects by meeting with the students regularly or participating in the design review process. Thank you for devoting your time and providing technical guidance to our students. Your advice and mentorship help students to achieve their goal and produce quality results beyond our expectations. And also, thanks to Capstone instructor team, and especially Prof. Ilan Ben Yakub for all his effort and dedication to the Capstone project this year. We truly appreciate the time and energy he has spent into the planning and preparation of this event. I really enjoyed when I work with him and see that he's investing a lot of time and energy to make sure that the event goes as planned. We are very fortunate to have him at UCSB. We would also like to take this opportunity to recognize the significant achievement of our students and congratulate them for completing their project in current unprecedented circumstances. COVID-19 crisis has undoubtedly had negative impact on most aspects of our lives, and our Capstone project was no exception. Due to the campus closure and limited access to the lab equipment and tools, many of our Capstone projects, especially multidisciplinary one, have been impacted. But we are fortunate enough to manage to adjust to all these new changes and keep students engaged with their projects using remote learning tools and technologies. We have redefined the goals and deliverables and pushed the project moving forward. Our students have embraced changes with open arms and work independently and collaboratively to achieve what they have planned for. Let's see a comparison between like this year Capstone project and previous year's one. This is what we had during past years. This is the Capstone Expo during the past years. And yeah, the students were able to showcase their product to the audience. And this is how the design review was in our Capstone this year. Yeah, and this is how our meeting was this year. So all on Zoom and virtual. This is how our weekly meeting looked like, and this is an example of recent changes and how we do things differently now. At the end, I would like to congratulate all our Capstone students for working together under such an uncertain time and achieving beyond the project goal. We greatly appreciate the work of our talented students who have involved in our mission of educating future engineering leaders. I now invite you to watch a short video montage of our industry partner projects. This will take about 15 minutes. We then come back to continue the rest of the event in this forum. But before we go to the video montage, I would like to invite your attention to highlight the significance of each of these projects in a few sentences. In this category, we have EOI Thermometer team, Helix HAL, Wolf-Switzenkai, and Sensiker Forest Field teams. So EOI Thermometer team has designed a small lightweight thermometer reference device that serves as a simple and affordable way to test the accuracy of a medical thermometer. This device helps doctor to take readings with confidence. Then we have the Helix HAL team. They designed a durable and accurate model foot and calf with embedded sensor and laser gauges that can reliably determine the fit of shoes in a time-efficient manner. This product improves the way shoe manufacturers test the comfort and accurate sizing of new shoes. And then we have Wolf-Switzenkai team, which they have developed a digital predisposition algorithm that enables the use of nonlinear energy-efficient power amplifier. This solution can contribute in developing power-efficient transceiver and help the advancement of wireless communication systems. In this category, the last project is Sensiker Forest Field, where the goal was to address the problem with current inefficient fire detection method by using a wireless integrated network of fire detection modules to collaboratively monitor large forest area. Forest Field platform can identify the location, fire location, the location with high risk fire factor and detect the fire instantly and monitor a fire as it spreads. The platform decreases the need for patrol and reduce the fire watch cost significantly. I would like now to invite you to watch the video montage of these 4 industry partner projects.
Hello and welcome. We are the electro-optical industry Capstone Group. Our product is ThermoSure, measure with confidence. Doctors' offices commonly experience the use of inaccurate and inconsistent IR thermometers. This is due to the cheap and easily available tech through means of internet. The error in these thermometers is off by as much as 0.5 degrees Celsius. Why, may you ask, is this an issue? Take into consideration the situation of a child. Incorrect diagnosis could be possibly fatal. Hence, it is our goal to create a device that tests the accuracy of these thermometers. This is a 3D rendering of our product. It is a 4 by 4 by 4 inch square box. In the front is the black body aluminum heating plate. On the top is an LCD unit to display the temperature of the heating plate. The product is going to be light, portable, and easy to use. One just has to point their IR thermometer at the center of the heating plate. If the temperature of the thermometer matches the LCD, then the thermometer can be said to be accurate. Here is an internal view of our product. On the front is the black body heating plate. Attached to it on the back are the 4 power transistors mounted via means of a bracket. In contact to the bracket are the heatsink and fan for efficient cooling. On the top is an LCD unit to display the current temperature of the heating plate. And to the right-hand side, we have our PCB with all the sub-circuits integrated into it. Also on the PCB is our microcontroller unit. Here is a high-level flowchart to better understand how our product works. A PRT, or platinum resistance thermometer, is inserted into the aluminum plate. A PRT is a highly accurate and linear thermistor. The change in the PRT due to change in temperature is measured through means of an STM32 microcontroller board. Then, power is delivered to the power transistors in order to heat the plate, or power is delivered to the fan in order to cool it. Furthermore, the current temperature of the aluminum plate is displayed on the LCD through means of the STM32 microcontroller.
Hello everyone, this is Adrian Alcacer from the EOI team here to show you our project demo. As you can see here, we have our custom PCB which integrates all our subcircuits. We have the microcontroller which is mounted to the PCB, as well as our power transistors which are mounted onto the heating plate. The PRT inside the heating plate is measuring the temperature which is being fed to our microcontroller. Here we have the computer displaying the temperature, which shows without any heating is at approximately 27 degrees Celsius, which is around 80 degrees Fahrenheit or room temperature. In this video, we have turned on the PWM. So as you can see from the computer, the temperature is steadily increasing. We currently have our reference point set to the 40 degrees Celsius. So as the temperature approaches, the PWM will slow down and deliver less power to the power transistors. Now that we are reaching our target temperature, the PWM is slowing down and stabilizing at our set temperature. As you can see, we are fluctuating between 39.5 degrees to 40.3 degrees Celsius.
Thank you for watching. Once again, we are Thermasure, measure with confidence. We would like to especially thank Electro-Optical Industries for giving us the opportunity to do this project, as well as our mentors and our professors, Professor Elon, Professor Reza, and Blake, for helping us throughout this project. Thank you.
Testing shoes for comfort has become a lengthy process of shipping shoes back and forth overseas to fix small defects in new shoes. With How, we hope to provide a faster solution to this process.
The next scene display is where all of our data and our interactive UI will be displayed. It is directly connected to our Arduino microcontroller. This is our Arduino, which is the microcontroller that we will be using. It is connected to the next scene display, provides power to our PCB board that houses our sensor net, that has our pressure sensors and distance sensors. This also goes to our SD card module and our Wi-Fi chip. This is our main connection from the Arduino to the PCB that has 6 rails. This is the PCB that leads to our sensor net containing our pressure sensors and our distance sensors. Here is one pressure sensor which is marked with P, distance is marked with D. This is what our pressure sensors look like. This is our time of flight distance sensor. This is the skeleton of the foot. It has metal screws to hold each sensor holder and have some mobility. This is our sensor holder. This is where our sensor head will go once we're able to open the compartment that where it will go. It consists of screws that, when unscrewed, it will be able to open up the compartment, and then we'll be able to stick our sensor inside and then close it back up so that it's properly secured. The holder opens up here. This is where the break happens, where after screwing it back on, that's where our sensor will be. There is a special sensor holder within each compartment that is specifically designed for each sensor so that it can fit in easily. We've also incorporated wooden dowels that, when pushed, it pushes against the sensor head, therefore being able to read any pressures, not directly to the head, but instead through the use of this dowel, which is basically the same thing as using the actual head.
The first page of the user interface is the home page, which presents the user with 3 button options. Starting at the left side of the screen, the user can choose to manually set the date and time. There's a default date and time already displayed at the bottom of this page, but it will update once the user has entered the correct information. On this page, the user can select the information they would like to input by first pressing the labeled text boxes. The accepted format is displayed above these boxes, and after the user has pressed the enter button for the date and time, they can navigate back to the home page using either the back arrow button at the top left or the home button at the top right. The current date and time is now displayed on the home page and is continuously updated as seen at the bottom of the page. The middle button on this page allows the user to begin selecting their preferred testing configurations. The first test options choice the user must make is the units that the data will be outputted in. They can choose from kilopascals, psi, or newtons per millimeter squared depending on their application. Next, they can select a threshold pressure profile. The first 2 options will be preloaded before they receive the product. The third option is to create a custom threshold for the pressure sensors. If they choose the custom option, They are taken to this page where they can name and save up to 6 different thresholds. Pressing on any of the nameplates takes the user to a keyboard page where they can enter the name of the file. The name will now appear in the nameplate that was originally selected. To actually set the value of the custom threshold, the user can press the measure button. Here there is a foot map with the pressure sensor locations marked with gray circles. The 8 locations are accompanied by 8 text boxes with the live pressure readings will be displayed. Once the user is satisfied with the threshold they are seeing, they can lock it in by pressing the save button. The result of the pressure test can be viewed by pressing the results button. This page will display 2 distance measurements on the left side of the page and the final overall grade on the right side of the page. The buttons on this page will remain gray until the distance from the heel of the foot model to the back of the shoe is sufficiently small, indicating that the foot model is positioned correctly. Once this condition is satisfied, the gray buttons will turn red if the pressure thresholds at those locations are exceeded and green if they are not. The overall result is given as a pass or fail. The data from the test can then be exported by pressing the export button. The user can go back to the home page using the home button at the top right. All the test options remain highlighted so the user does not have to remember the exact configurations they selected. The last button on the home page is used in the case of a malfunctioning pressure sensor. Here the user simply selects the location or locations where they have changed sensors in order to update the address in the Arduino code. The sensor locations is selected and change color to indicate that the sensor has been replaced.
Hi, we are the SenseSeeker Force Field Capstone team. My name is Jeremiah.
My name is Prathamesh.
I'm Ryan.
I'm Jeffrey.
And yeah, we are forest fields. So to briefly describe our problem, in recent years, forest fires have become increasingly erratic, more powerful, and have cost thousands of, or if not millions of dollars in damages and countless human lives.
And we believe we have developed a solution to speed up the response time for forest fires using an array of sensors in a mesh network and a visual interface to display the data transmitted from the sensors.
So here is a rough overview of our project. So here we have the block diagram depicting the project as a whole. So we have a group of environmental sensors which are communicating via a mesh network. These all talk to a concentrator node which has 2 antennas, one to communicate to the mesh network and one to communicate to a LoRaWAN gateway, which establishes a connection to the internet via a cloud server network called the TTN. So this node that I'm holding right in my hand is a concentrator node and has multiple lights attached to it. The blue light indicates that it is receiving data from one of the other nodes in the network. The number of flashes indicates the node ID, with the red light indicating if the mesh network is actually functioning properly, in that if data is being transferred from one node to another node and then from that node to the concentrator, thus having a multi-hop network that is indicative of a mesh network. And so the concentrator takes the data off of the mesh network and uploads it to the TTN. So here you can see all of the data coming into it. So in this application UI, you can see that we have the CO2 content, the humidity, the temperature, and the node ID, with the node ID being the node identifier, which allows us to take that information from the cloud-based server and convert it into a form which we can sort of process and analyze later.
This is our web application. This is how we visualize the data that our sensors are gathering. So as you can see, each of the sensor nodes, each of the locations of the sensor nodes are marked by a marker on this map interface. This map interface uses the leaflet library to display this map using Python. As you can see, when you click on each node, the sensor data from each of the nodes is displayed in real time, and the location of the nodes are also shown here on the map.
Awesome, and our network is enabled by a series of Arduinos that are hooked up to RFM95 LoRaWAN modules. And here you can see some of the serial monitor output of the LoRaWAN concentrator, as it basically takes in data and sends it to the network for analysis. And so this is basically the hexadecimal expression of the CO2, the temperature, the humidity, and the node ID, which is compressed into a 7-byte payload, which is sent from the concentrator to the TTN via the LoRaWAN gateway. And here you can see one of our nodes actively working, as it is collecting these numbers, which are the CO2 and data, which are the data that we are transmitting, and then we are sending that payload to the concentrator. Huge thanks to everyone that helped us out with this project, especially the people at SenseSeeker. And per Ilan's statement during our final presentation, we are officially the kings of mesh networking.
Hello, everybody again. I hope you have enjoyed the video for this industry partner project teams. And sorry for the technical difficulty. Yesterday, we have actually tried this on Zoom and integrated all this video in Zoom, and it worked fine. And today, probably it's because of the large number of participants who had this issue. All right, at this point, I would like to invite Jenna Georgieva, our electrical engineering student representative, to talk about her experience during her 4 years of study at UCSB. She will also be talking about her capstone project experience during this year and speaks about the ups and downs she has seen over the course of this project, especially during the time that we all have been impacted by COVID-19. Jenna?
Hey guys, I'm Yana. It's great to be able to connect with everyone today, and I'm glad we could all get together to see how our projects have turned out. I know it hasn't been the easiest or most satisfying end to our capstone program, nor our years here at UCSB. But I'm hoping we can at least take comfort in the fact that we have accomplished something worthwhile that we can look back on in the future. Being a part of Capstone has been a rewarding experience, both as a culmination of all that we've learned in the past 4 years and as a new opportunity to design and create a project from start to finish. Also, it's been really great to see so many projects that have the potential to be life-changing for many people. I know that many of us had that motivation in mind when we set out to be engineers, and it is truly amazing to see it happening in reality. For my senior capstone this year, I was lucky enough to be part of an exceptional group and a project I was excited to work on. As a member of the Baby Joy multidisciplinary team, I had no shortage of talented team members to collaborate with and learn from. It has been extremely eye-opening to have been able to work with so many people of different specialties. Of course, working with a large group came with its own challenges, and often we struggled to come up with solutions that addressed everyone's concerns. But with the help of our advisors and TAs, I'm proud to say we successfully managed to create a functioning prototype. This last quarter especially, I was continually impressed by my team members' drive and determination to finish this year strong, even in this difficult time. My team managed to successfully troubleshoot problems, across Zoom and countless internet issues. It turns out that a global pandemic and a stay-at-home order tend to make collaboration a bit challenging. Who knew? However, one of the highlights was witnessing two of our group members, Suhail and Brad, attempt to program our malfunctioning motors while being more than 300 miles apart. It took them multiple days, and yet somehow they managed to stay sane and finish on time. Through all the burnt out motors and unfortunate electrical burning smells, it feels amazing to see our project come together. I've had the privilege to check in with so many of the other teams presented here today, and it's honestly really cool to see how far all these projects have come each quarter. All the project titles we sifted through in the beginning of the year, trying to find our best fit, are now well on their way to being actualized products. Every single person here should be proud of themselves and their groups, of what they've been able to overcome in the face of both technical and circumstantial challenges, of what they've learned from these projects, and of what they've been able to achieve in just one short year. In addition to the Capstone program, there have been countless other experiences, as well as people in this department that have made my undergraduate experience worthwhile. Throughout my time at UCSB, I've been especially inspired by the women I've met in our field, both on campus and in the entire UC community. Being here has not always been so easy for me, and I had a tough first few quarters in this field. I was around far less women at UCSB than I was used to, and it felt strange having that as my new normal. It wasn't until I made supportive female connections that I found my own sense of well-being and was able to thrive. I love to see the growth we've achieved by supporting one another and providing insight, which was especially helpful since we have all walked the same path. But beyond these connections, I also have a lot of appreciation for everyone who in these 4 years has given me guidance or advice. I am grateful to those who stayed late to help me with homework, or even just took the time to tell me about a research opportunity. The support of my fellow classmates, male or female, keeps me motivated to push through challenges and continue learning and working in engineering. I love this major and appreciate all the people it has brought me in contact with, professors, TAs, graduate students, and undergrads. I'll always remember the countless late nights in Cecil, working through PN junctions, or trying to master the mystery that is cadence, and the many hours spent in the 137 lab learning that sometimes power amps just have a mind of their own, and only the magic of the TAs can make them listen. I know that these and many other shared experiences have brought us closer together. I hope all of you have been able to find a community here, whether that be on your Capstone team or beyond. It's been a unique 4 years, and we have really been through it all. The Thomas Fire, mudslides, the Cave Fire, the mountain lion, which was actually a bobcat, and now a pandemic. At least no one can say it's been boring. But amidst all the chaos, I'm proud to say we have pulled through. We have shown that UCSB engineering is not confined to ESB or HFH, but exists within the bonds we have formed with one another. With that, I'd like to thank some of the people who have made it possible for us to conclude our Capstone program and our years at UCSB. Thank you, Professor Ilan Benyakov, for being available at all hours of the day and taking the time to teach us what having a 401k actually means. You know, for those of us who are financially clueless. Also, a personal thank you to my group's advisors, Professor Tyler Susko and Dr. John Jacobs, as well as Professor Reza Abdoli and the TAs, Blake, Evan, and Eric. Without you guys, I know my project and probably many others would have simply remained unfinished ideas. I'd also like to acknowledge the many professors and staff who made it possible for all of us to learn in the first place. I had a really fulfilling 4 years here in the electrical engineering department, and I'm excited to take the next step in life as a graduate. I wish all of you the best of luck in whatever you decide to do in the future. Thank you, everyone.
Thanks, Yana. I think you just stole the show here. So I first met Yana 4 years ago when she came to visit her sister here at UCSB. Her sister at the time was a senior in our department in electrical engineering. She's one of the original members of our UCSB Hyperloop team. And I think I think you've been in probably about a half dozen classes of mine by now. And it's been a real pleasure to watch you grow and mature into the leader that you've become today, as clearly evidenced by your eloquent speaking ability. So congratulations to you.
Thank you.
Okay, so we're going to now move on to our research lab project. So the next 4 projects that are going to get featured are ones that were completed in conjunction with a research lab here at UCSB. So Team Rio worked under the guidance of electrical and computer engineering professor Hua Li and his grad students Vince Radzicki and Connor Sanchez to design and build an electronic stethoscope that includes an array of microphones, which allows the device to be able to localize the sounds that it picks up. Inspecco, this was Shannon and Frank's project, and they worked on this. Inspecco is a control system for the Impress LiDAR system being developed in Professor Jonathan Clampkin's lab. So Impress is a compact LiDAR system that can be flown in small satellites above the Earth's atmosphere, and it uses a pair of lasers to measure the concentration of carbon dioxide or other gases in the atmosphere. Team WearCare has been developing a wearable blood flow monitoring device that will eventually be able to detect when blood flow in the lower limbs has been reduced or otherwise impacted over a period of time, and alert the user to take action before complications such as deep vein thrombosis occur. And finally, we have Cyclus. So Cyclus was a collaboration between professors Forrest Brewer, Joao Espana, and myself. We worked together with this group of 5 students, and they jointly developed a platform that can be used to design and test motor control algorithms for driving modern electric motors more efficiently. Okay, so we're gonna try this once again. I'm gonna try to start the video, and just in case this doesn't work, Evan's going to be just posted a link to the YouTube, a YouTube link in the chat. So I'm going to try to start this now. Hopefully it'll work, and if not, we'll stop it and you can go to the YouTube link.
The stethoscope is simple in design and is pretty easy to use, but it does have some significant drawbacks. For our project, our goal was to make an electronic alternative to the stethoscope, specifically addressing 3 of those drawbacks: inaccurate sound perception, uncontrollable sound amplification, and the lack of acoustic data collection. We chose those 3 because they play a pretty big role to hinder doctors' efforts to treat patients. Because the stethoscope can't accurately reconstruct the input acoustic signals every time, doctors have a 40% chance to misdiagnose the patient. And also, if anyone's ever worn a stethoscope and tapped on the diaphragm, you would know that it would generate a super loud sound. Doctors do that accidentally as well, and since they use stethoscopes on a daily basis, they often receive permanent hearing loss. And finally, because mechanical stethoscopes can't record data, doctors don't have data to reference and might be inconsistent in subsequent diagnoses. So to address these problems, we considered the following. Delay and some beamforming is a signals processing technique that allows us to isolate a particular sound source within a noisy environment. And because everything is electronic, we can easily implement some form of volume control and data collection. The end result is Rio, the world's first beamforming electronic stethoscope, designed to minimize the risk of misdiagnosis and detect heart defects without EKG or imaging. Using this powerful device, doctors can diagnose and provide treatment without having to run uncomfortable tests. Rio is comprised of a 4-element array that is designed to contour onto a patient's chest, maximizing acoustic coupling and patient comfort. This right here is Rio's computing unit, which houses all of the computing components. It is the heart of our device. Rio also features accessible volume control, expandable micro SD card storage, and a 3.5mm headphone jack. A durable flexible PVC cable protects all internal wiring, and provides a familiar touch. By utilizing beamforming technology, Rio is able to reveal heart conditions that would otherwise be hidden within the noise of the incoming heart acoustic. One heart defect that is often masked by noise is aortic regurgitation. Normally, The heart valve opens and closes to control the flow of blood in and out of the heart. When the valve doesn't close correctly, blood meant to go out of the heart rushes back in. Aortic regurgitation can cause severe heart complications which can ultimately lead to death. It's important to recognize early signs of aortic regurgitation to determine whether or not surgery is needed. Ryo reduces the noise in the incoming heart signal to reveal spectral features associated with aortic regurgitation. By taking a short time Fourier transform, Ryo warns the doctor of potential valve defects. In later iterations, Ryo will be able to detect a plethora of heart conditions. All potential defects found are reported to the doctor using our easy-to-use graphical user interface. This is the future of heart auscultation. Tune into your heart with Ryo.
Global warming is becoming a greater issue and will continue affecting the world we live in. Because of this, it is important for us to monitor and control the effects of greenhouse gases such as carbon dioxide. Inspecco contributes to the global warming crisis solution. Organizations such as NASA have been using LiDAR systems that orbit Earth and detect CO2 gas concentrations. They have incorporated discrete components, and the downside to these systems are that they are big and bulky and consume lots of power. What Impress LiDAR proposes is to decrease the cost, size, weight, and power by using integrated photonic technologies. Impress LiDAR is a research project done at UCSB that has already developed a photonic integrated circuit, or PIC, for the LiDAR system, but is in need of a user-friendly control system. This is a high-level block diagram of the Impress LiDAR system, which has the control electronics and the PIC. The photonic components of the PIC, which are shown in yellow and orange, are controlled by the hardware components, which are shown in gray. But for this project, we'll be focusing on the control electronics to control and monitor the PIC. The PC is used to develop the firmware and run the user interface. It also sends commands to the FPGAs from the interface. The FPGAs then send and receive data from digital to analog converters, or DACs, which convert set voltages to laser drivers and temperature controllers. The laser drivers and temperature controllers control portions of the PIC. And now let's show how the user can set voltages to the DACs using the interface. The user can first select the laser driver, which finds the DAC and generates an address for it. The user can then input temperature for the temperature controller or current for the laser drivers. Then the voltage is calculated from the information and converted into binary data. This data is then sent through I2C communication to the corresponding DAC. Here we're showing how the data is being processed from the interface, and this shows how the data is being sent sequentially inside the firmware. The user-friendly interface has two sections, the control panel and the output indicators. The control panel allows the user to enter the desired current or temperature while selecting the section of the PIC. The user can then send this information to the firmware where it receives the DAC address and data to send. The output indicators allow the user to see voltage levels that are set by the DACs at the corresponding laser drivers or temperature controllers. The intentions were to be tested on the PIC, but so far we have only been able to test on LEDs. Because we are able to control the LEDs using the interface, this proves that we can control the Impress LiDAR system fairly easily. And now we can replace big satellites with small satellites. Thank you for watching.
All right, hope everybody enjoyed those videos. So up next, we're gonna have Professor Luke Theogarajan from our department step on and give us and offer up a few words of wisdom. Luke, thanks a lot for joining us. I'll pass the mic to you.
All right. I don't know about wisdom, but I will try. I mean, it's especially after Yana's speech, it's going to be extremely hard. So, I mean, it's not going to be as good as that. I can tell you that much right off the bat. So, first, I want to thank you, Ilan, for giving me the opportunity to say a few words to the graduating class of 2020 in EE. First, congratulations to all the students who have worked so hard on their capstone projects. These are unprecedented times. The pandemic has upended all our lives. The future seems uncertain to many, and injustice in the world is only growing. But today, we set all that aside for a few moments to celebrate your accomplishments. Capstone is a culmination of all the long nights of hard work, studying for your classes, doing homework and projects. In fact, Capstone is named after the architectural term indicating the final crowning achievement, for example, in a building. As I've looked through your projects, your creativity, hard work, and persistence clearly shows through. Some of you have chosen projects in the field of biology, environment. I even saw a project on a rocket. This is truly impressive, especially at the stage of your education where you are. And some of you worked on things to help children, some with surgery. I saw this really cool motor just a few minutes ago. These are great projects, and all of you should be really, really proud of what you've achieved with all of this uncertainty in front of you. Each project shows me that you are ready to face the challenges ahead. I've had the opportunity to teach a very few of you over the years, and I'm sure in the face of all these enormous challenges that we've all faced, I'm sure that my exams right now don't seem that hard. It has been a privilege to be a small part of your academic journey. I would like to take this opportunity to thank Ilan, Reza, and Yoga for their exceptional leadership in leading the Capstone projects, the TAs for their dedication, and the staff who have helped you through this incredible journey. These are unprecedented times with numerous challenges that might seem daunting. I have seen what you all can do when you set your minds to it. The question I would ask you is, what can you do to make the world a better place? A safer, more equitable world for everyone. I expect great things from each of you. I leave you with this one saying from Gandhi: be the change you wish to see in the world. Congratulations, class of 2020 in electrical engineering.
All right, thank you, Luke. That was great, and also want to just thank all of the faculty members. I see quite a few in our participant list who joined today. I know it really means a lot to the students for you guys to join and for them to be able to share what they've done with you. Okay, so moving on to multidisciplinary projects. So this is the last group of videos that you'll see featured today. So all of these projects were carried out by larger teams that have electrical, mechanical, and in some cases computer engineering students. So while only the electrical engineering students will be pictured here, and just know that they were actually part of a much larger team that included many more students as well. So the first team that we're going to hear from is Baby Joy. So as you heard from Yana before, Baby Joy developed a device for providing automated ball therapy to infants with cerebral palsy in order to increase the total number of therapy hours that young children with CP are able to receive. So the second video is going to be from a group of students that worked with True Digital Surgery, a local company that has developed a robotic surgical microscope. So the students have developed a training tool that they have called the Core 5, and surgeons can use this training tool with the microscope in order to quickly master all the features of the microscope. And the final video is going to be from the UCSB Rocket Propulsion Laboratory. So this is a student engineering group that was formed last year to design and build a rocket fueled by liquid oxygen and methane in order to compete in the Far Mars rocket competition that's held every year in the Mojave Desert. So this year's project was aimed at designing the propulsion system for the rocket. Okay, so once again, we're going to move into the videos, and Evan is going to Evan just posted a link to in the chat to the last set of videos. We'll try and see if we can get this working. And if this doesn't work out, then just switch over to the YouTube link, and we'll see you back in a few minutes.
Baby Joy is a multidisciplinary team at UCSB, and we aim to create an automated therapy for infants with cerebral palsy. CP is caused by a brain injury and affects mobility throughout a person's whole life. Walking difficulties and other disabilities can help with frequent therapy. Specifically, ball therapy helps to encourage the muscle growth from very young age, and we want to intimate that motion at home.
To develop a new motor pattern, the infant or child needs to repeat it so many times, such a high number of repetitions. It's hard for a parent to just sit there and do it over and over again. So if it's something that's a little automated with the parent's close supervision, that it could be a very effective tool.
A previous version of this project was made successfully, but would not fit into the home. So our goal is to make it smaller to provide easier access to automated therapy for families at home. Over the course of this year, we have put together the Baby Joy. It is a compact, safe, and user-friendly therapy device with a range of helpful features. The infant is securely strapped onto a costume-shaped platform that keeps the baby comfortable and safe during the motion. The motion of the Baby Joy is controlled via two motors placed underneath the baby platform, which provide therapeutic motions to effective angles and speeds. During the current pandemic, we have to finish much of the construction separately to overcome the distancing conditions. Walking independently is challenging but rewarding. At the end, through our many video calls, we managed to put together our prototype and program a test motion sequence for the motor system. Since the Baby Joy is a medical device and needs to undergo testing before it can be used at home, we built it as a research tool. The data collection for this is done through numerous sensors that can tell us the duration of the therapy sessions and if the infant was interacting with toys. We're also placing a crying detector so we can know when the infant might feel distressed. This sensor can detect certain frequencies of a baby's cry and can let us know if the motion is making them uncomfortable. In order to make Baby Joy user-friendly, we have developed an easy-to-use app that can be accessed on the tablet of the device. With several modes to control the motion, we wanted to deliver a well-rounded control system. To achieve this, there are options of pre-recorded motion sequences or manual adjustable motion control. Baby Joy can also connect to any handheld device through Bluetooth. Moving forward, we'd like to see this project physically integrated and properly tested. We're hoping to implement all the needed sensors and finalize the design to make it more affordable. We believe it will change the futures of many children with CP and improve their lives.
Welcome everybody. In this video, I'm gonna show you how the UCSB Capstone team help improve the performance of surgeons using the most advanced surgical microscope. Every year, there are more than 4,000 surgical errors happening in the United States, meaning that an advanced tool is much needed in a real surgery. The company True Tissue Surgery created EOS, an advanced surgical microscope that provides strong functions and brand new features which could help surgeons in a real operation. With the help of EOS, surgeons are able to have a clear 3D display of their operation area from different angles. The camera can also help them identify objects that cannot be seen by human eyes. However, the only problem with EOS is that it requires a long and tedious training process. Traditionally, surgeons won't spend 2 hours reading through the user manual before the surgery begins. They need a quick start. And here we are. The UCSB Capstone team created this quick start. We designed a training environment that could significantly reduce the amount of time that surgeons need to be trained. The brand new training environment is composed of two parts, the metal model and the software aligned with this metal model. In this new process, the trainings are required to complete a series of mini games, following the instructions on the software and perform certain movements on the metal part.
Hello everyone, our team is part of the Rocket Propulsion Laboratory, a student-run aerospace club on campus, working to further innovation in rocketry for the next step in human space travel. We aim to take part in the Friends of Amateur Rocketry FAR Mars competition, which challenges students to design and build a rocket that reaches an apogee of 45,000 feet using liquid oxygen and liquid methane as its fuel. However, before the rocket can be entered into the competition, a successful static fire test of the engine must be completed, and the engine's performance and safety must be documented and submitted to FAR. That's where our team comes into play. The electronics team is responsible for providing a control system for the engine, as well as a means to gather, transmit, and process data from the rocket engine during the static fire test. We split our project into three main systems: controls, sensors, and the graphical user interface, or GUI. The control system will be responsible for the electrical actuation of solenoid valves to direct fluid flow during the static fire. They will also be responsible for pre-programmed sequences from the microcontroller to control the valves for different parts of the test, such as fueling, firing, and abort. Additionally, they will be in charge of the REDS, or Rocket Emergency Depressurization System, a standalone system that allows emergency tank depressurization prior to launch required by FAR. Lastly, they will be assembling a control box in the bunker for the operator to start different sequences and manage the rocket during the fire. The sensors team will be responsible for measuring temperature, pressure, and force at various points on the rocket to collect data for FAR, as well as monitor the status of the system during the test to verify functionality. They will also be responsible for determining the proper method of mounting to collect data and calibration for high accuracy. Lastly, they will be in charge of programming the ADCs for conversion of analog sensor data to digital so it can be input and transmitted by the microcontroller. Lastly, the GUI must be functional and easy to read so the team can monitor sensor data remotely during the static fire test. And they're also responsible for data transmission. In this case, the communication protocols UDP and TCP using Ethernet to guarantee reliable data. Here is a functional block diagram of all the elements and interconnections of our system. First off, all the systems you see in the gray box are on board the test rig inside a specially cooled and dried housing. In green is the control system, comprised of the main microcontroller with pre-programmed sequences, a relay array to control the valves, as well as a power conversion system. The control box on the right will be composed of various switches to manage the rocket, as well as LEDs and an LCD to provide live status feedback. The sensors in orange will be connected to the onboard microcontroller, taking advantage of its onboard ADC, which will be relaying this data via Ethernet to the computer located in the bunker. There, the data will be stored, processed, and displayed on the GUI for the operator to manage the state of the system during static fire. Now that we have gone over the system requirements and components of our system, we will show a video demoing the complete GUI as well as its integration with the sensor array prototype.
Hello everyone, my name is Garrett Clover and I will be discussing sensor integration for the RPL static fire test rig. I will first go over the physical integration of our sensors, and I will then demonstrate how the sensor works with the graphical user interface. The picture that we are seeing right now is of a compressor that my family happens to own, and it's connected to the pressure transducer, which is fastened to the yellow hose on the left that allows air to flow out of the compressor. And this is our integration circuit that scales our sensor's output to a voltage range that the STM's ADC can take in and convert to digital values before sending this data to the bunker computer. The white and green cables on the left are the data output pins for our sensor. They are going into the instrumentation amplifier, which is the black chip in the middle. The 285 ohm resistor just above the instrumentation amplifier is our gain resistor, which allows us to modify the gain of the amplifier to scale the sensor output to whatever value we choose. And we have selected this value to fit our ADC's input range. So on the right we have our raw data that is being read by the GUI. All of them are in int form. And then on the left we have our line charts. All of them are zeroed out except for the one on the top left because that is what our pressure transducer is feeding in. So at this point I've turned on the compressor and you can see the pressure steadily rising, and as it does, the axis on the left, the y-axis, is auto-adjusting to scale with the range of data that it's showing over the last 30 seconds. As you can see, it just went from having 10 psi between each tick to now having 20. And then I've turned the compressor off and I've just pulled the plug that is depressurizing that chamber. So it is returning back down to normal.
Hello everyone, my name is Mingji Li. In this video, I'll be demonstrating our graphic user interface. This is the starting page of our GUI. In here, we need to properly set up the IP address and port. Once the connection is verified, the GUI will start data transfer and display PNID, which is shown here. In this window, we can activate the bar chart and line chart. This is how our bar chart looks like. And this is how our line chart looks like.
Okay, hope everybody enjoyed those short video snippets of all the projects that our students worked on throughout the year. So now we're going to move on to our awards. So in most years, we only give out team awards. So I'm a firm believer that the most important contribution that any individual on a team can make is to empower other members of their team to contribute. And so their individual contributions are embodied in the performance of the team as a whole. However, this year we had the unusual situation that about 2/3 of the way through the projects, everybody had to start working remotely. Lots of students had to move back home. Some moved overseas. So a few people are actually joining us from overseas right now. So for many of the teams, what started as a group project was somewhat transformed into a group of individuals working in conjunction with one another, but physically separated in order to develop the product as best that they could. So as a result, in addition to our team awards, we decided this year to add an outstanding individual contributor award that this year will be awarded to 4 students. So the team awards were selected by myself and the rest of the instructional team based on our observations and working with all students throughout the year. And the 5 team awards for this year are outstanding collaboration, distinguished technical achievement, outstanding innovation, outstanding product design, and the highest award that we give is the Excellence in Electrical Engineering Award. So for the individual contributor awards, we let the students decide on these. So we asked all the students to submit nominations for any of their peers that they believed deserved one of these awards. And I have to admit, I was really touched by what many of you had to say about your classmates. For me, reading these nominations was kind of really a highlight of the last few months. So each of the students selected to receive this award was nominated not only by several of their teammates, but also by other students in the class who'd seen their work and presentations throughout the year and just felt that they deserved to be recognized for all of their hard work. Okay, so we'll get things kicked off with our outstanding individual contributor awards, and then we'll move on to team awards. So our first outstanding individual contributor award goes to Suhail Chakravarti. So Suhail was a member of the Baby Joy team, which, if you recall, was one of the large multidisciplinary projects. You just saw the video not too long ago. And so over the years that we've run these larger projects, what we found is that for these large multidisciplinary projects, the technical challenges that need to be solved are not really the hardest part of the project. In fact, I'd say they're kind of far from it. The hardest part of the project is what seems kind of basic, but just getting everybody on the team to work on a schedule and work together and come up with a decision-making process so that everyone can agree on how to proceed and how to best support one another's efforts. And so as a result of that, these projects typically take a lot longer than the smaller projects to get moving. And I'd say for the first couple months of the Baby Joy project, it kind of really was falling into this trap. And the team could have quite possibly stayed on that track if it had not been for Suhail's efforts. So I could tell you all about Suhail's contributions, but I think they're best summed up by one of his teammates who wrote the following. Suhail was a great team leader and a really good bridge for our multidisciplinary team. Since our project had a mechanical inclination, it was difficult to integrate the EE members sometimes, but Suhail was very good about communicating that to everyone throughout the whole year. Also, he was super dedicated and always respectful of people's abilities and delegating tasks according to their areas of expertise. He always tried his best to provide resources to people who maybe didn't know certain topics, which was insanely helpful to the project. Overall, a great team leader, and I'm happy to have been on the team with him. So luckily for me and Reza, today's not a goodbye to Suhail. He's staying on here at UCSB next year to complete his master's in electrical and computer engineering. And we're lucky enough that he's going to be one of our TAs for Capstone next year. So congratulations, Suhail. All right, so now I'm going to hand things over to Eric, who's going to present the next couple of individual contributor awards.
Hi, everyone. So the next award goes to Yilong Zhang from Core 5. As the team leader for Core 5, Yilong coordinated the inner workings of his team throughout the year, from effectively delegating tasks to his team members to running weekly meetings. Yilong kept Core 5 on track, both in technical content and various project deliverables. Yilong's high-quality graphic designs can be seen in both the Core 5 logo as well as the graphical user interface of the team's completed software. It's been a pleasure working with you. Congratulations, Yilong. And the next award goes to Julian Maravilla from the Rayo project. So Julian has consistently demonstrated his exemplary technical knowledge, project management, and leadership during weekly meetings and presentations. While leading weekly meetings, Julian often stepped up to answer difficult questions. And Julian's innovative ideas and technical contributions were key in defining and propelling the project from open-ended research onto its final form. To quote one of his team members, "There is no group without Julian." Congratulations, Julian. And now I'll hand it off to Blake for the last individual award.
Thank you, Eric. So our final Outstanding Individual Contributor Award goes to Ethan Lamb for his work on the Wolfspeed Senkey project. Now, Ethan's outstanding performance this year was noted by everyone in the class, from instructors to TAs to classmates and his own teammates alike. Now, the name of the award is Outstanding Individual Contributor, but that does not really do it justice in Ethan's case. Yes, he's receiving this award because of his diligence and incredible technical engineering contributions throughout this project. But not only that, he has shown exemplary leadership traits by encouraging and supporting his teammates throughout a successful project. Congratulations, Ethan, and great job. So that was our final individual award. Now we're going to be moving on to the team awards. So the first award is for outstanding collaboration in an electrical engineering project. To effectively communicating and working as a team is absolutely critical to ensuring a successful engineering project, as we all know. The award for outstanding collaboration in electrical engineering goes to Team Baby Joy. This year, I had the absolute privilege of working directly with this team and its members. And not only did they create an excellent project for a worthy cause, but they did so in the face of difficult external circumstances. Every member of this team knows when to step up and when to step back, how to communicate effectively, and how to work as a team, which is the ultimate compliment to their engineering prowess. Congratulations and great job to Team Baby Joy. Now I'm going to hand it over to Evan to present the next award.
Cool. Thank you, Blake. So the next team award that we have to present is the Distinguished Technical Achievement in Electrical Engineering. Now, this award is awarded to a team that not only did great technical work throughout the year, but also embodied what it means to actually be the electrical engineering team and learn all the things that go into that process. So with that, we present this award to Team Cyclists. So I actually had the great pleasure to work with this team, just as Blake had the pleasure to work with Baby Joy. And I can tell you that this team's project was nothing It was very far from simple. They took a very, very complicated technical project and was able to convey that message clearly to an audience that would not necessarily understand what they were doing. However, in addition to that, their technical achievement was outstanding. They were able to promise something at the beginning of the year and completely deliver upon that, creating a complete motor control drive platform that's enables everyone to use motors more efficiently. Not only this, but they were able to use each other's technical experiences in parallel to what people do the best. So for example, not only did their project include a motor control algorithm, but they also designed custom FPGA blocks. They were doing simulations, helped make custom PCBs that they all integrated together to make motors run more efficiently. So not only did they do a great job in technical development, but they also worked really well in parallel and got a product done by the end of the year. So great job, cyclists, and I loved working with you guys. With that, I'd like to hand it off to Reza Dooley to present the next award.
Thank you, Evan. The next team award is the Outstanding Innovation in Electrical Engineering. This award is given based on the novelty of the proposed technique and the incorporation of advanced theoretical concept into a physical device to improve its functionalities. This year, this award goes to Ryo team. This team has successfully designed an electronic alternative to the traditional stethoscope, which revolutionizes cardiac oscillation. By implementing multiple receiver and using the state-of-the-art signal processing techniques, Ryo device can output clean, detect-free signals that greatly reduce the risk of misdiagnosis. I had the privilege of working with Ryo team this year. We met regularly each week. The team has shown nothing but an exceptional performance. Their delivery each week exceeded my expectation. The team has always embraced harsh criticism with high level of professionalism, and they applied them into their work to improve the design. There were many occasions when the team has pivoted the project direction based on our feedback. They were always energetic and welcome the changes. I'm very confident that everyone in this team will be very successful in their future engineering or academic career. Any company or institution hiring them will be very lucky to have them. Congratulate Ryo team. All right, the next team award is the Outstanding Product Design Award. This award is given based on the product design strategies, engineering principles, and the marketability of the end product. This year, this award goes to EOI Thermometer team. This team has come up with a lightweight thermal reference device that serves as a simple and affordable way to test the accuracy of medical thermometers. The device ensures that doctors use accurate thermometers and take readings with higher confidence. This team has designed the first portable, low-cost medical thermometer reference device. Thermometer team project has been sponsored by electro-optical industry. The involvement of the company was crucial for the success of this project and the learning process of the student. During the course of this project, the student got the corporate experience, foster teamwork, and learn the new technology used in this company. I, as a faculty advisor, provided a high-level technical guidance, lead the team to meet the benchmarks, and manage their overall progress. During the course of this project, I have really enjoyed working with each individual in this team. The teamwork and collaboration spirit in this team was truly exceptional. They know how to utilize the advanced software and tools in their advantages in designing the product. This was reminding me of the time when I was working for fast-pacing high-tech company like eFabless Corporation and Qualcomm. I congratulate Thermometer team. It was a great pleasure working with you. And now I'll pass it to Elon for the next team award.
Okay, thank you, Reza. So our final team award, the highest award that we give, is the Excellence in Electrical Engineering Award. And this year's winner goes to Team Senkei. So this team, you saw them before. They worked both with their sponsor Wolfspeed and also with Professor Jim Buckwalter from our ECE department on a high linearity amplifier design and an accompanying digital pre-distortion implementation to reduce noise. So I could go into a lot of detail about the technical aspects of their project and why this team deserves this award. But to put things simply, this entire group outperformed most graduate students working in the same field. So the technical complexity of this project was about as high as any project we've taken on in Capstone in the last 10 plus years. And this team really just knocked it out of the park. So I met with them weekly throughout the year, and pretty consistently, each individual on the team would be able to share some significant contribution that they had made since the last time that we met. So I also happen to be related to someone who's a top-notch RF engineer at Sonos for many years. If you're not sure who she is, we share the same last name anytime she's not running for the Goleta School Board. Sorry, shameless plug there for her. But anyways, during this last spring quarter, she listened in on a few of the Zoom meetings that we had. And she told me afterwards that while she was at Sonos, she interviewed a whole bunch of RF engineers that had recently finished their master's degrees at prestigious universities. And Sonos even hired a few of these. And none of them were as good as the students on this team. So Chen, Stefano, Ethan, Emmanuel, Hamilton, congratulations to all of you. It's been an absolute pleasure working with you guys this year. Okay, so we're gonna try something really quickly here. I'm going to stop this video share for just a minute. And I know it's Friday afternoon, so hopefully that means that everybody's got a drink on them. So we're gonna try to unmute everybody right now, and let's give all the teams a hand and have a toast to them. So hopefully we don't get too much feedback here. But let's give everybody a big round of applause.
Great job. Good job, everyone. Cheers.
Cheers, everybody.
Cheers.
Nice. I'm drinkless. Doing it right.
Right.
If I had champagne, I'd like pop it open.
Okay, so I'm just gonna, I think I've muted everybody back again. Sorry, I'm gonna go back to the share screen and finish this off. Okay, so in closing, to all of our students, I remember when I finished college a few years back and I was celebrating with my friends, and we all felt a real big sense of both accomplishment and relief. And while it's a bit unfortunate that this year we don't get to all celebrate in person, know that you've been an inspiration to me and all of us who've been involved with Capstone this year. So in March, all of you had really gotten to the point in your project that you were ready to kick it up another gear and finish strong. And suddenly when the shelter-in-place order happened, I really thought we were done for the year. I didn't know how we were going to keep going. But as we all saw, lots of you found really creative ways to keep making progress. I'm really impressed and really proud of what all of you were able to do. And also, so my weekly Zoom meetings this spring with all of you were probably one of my favorite parts of working from home. So I know we kept things a little bit more casual than what we usually do, because that's what you do when you're working from home. But But for me, they really provided a personal connection and a creative outlet that was otherwise missing from my life. And I really hope that they did the same thing for you. So I thank all of you for that and wish you all the best of luck in your future endeavors. And to all friends, family, colleagues, and everybody else who are still here, thank you so much for attending this event and supporting this wonderful group of students. Hope everybody has a great weekend, and hopefully next year we'll get to see all of you in person. Thank you and goodbye.